If we were to sum up what we're going to be talking about today, just in one simple phrase, it's use sub workflows. But the methodology and the thought behind how we create sub workflows, why we create sub workflows, and everything in between is what we're going to be focusing in on today. By creating sub workflows, we're going to be creating in a more modular fashion. And when we create modularly, one of the big topics and ideas that revolve around this is this idea of abstraction. A lot of this stuff comes from software development, software programming, software architecture, just like many of the other concepts. So this is adapting what the forerunners of where we are today have devised in order for us to really utilize this idea of modularity and abstraction. The story so far is from the software development world, we've taken principles like dry, don't repeat yourself, easy to change or easy to configure, as well as defensive automation through things like error handling. Now, the other two things we're focusing in on today is abstraction. How can we take complicated processes and only focus in on the high level aspects of it, and modularity? How do we break apart pieces of our automation so that we can reuse those parts in other places? The analogy that you'll often hear when designing modularly is as if we're building with Legos. So let's go ahead and dive in and first talk about this idea of abstraction. And at a very high level, when we talk about abstraction, it is focusing on the high level. It's focusing in on the details that matter most and taking a lot of the complexity and tucking it away somewhere so that we're not as concerned about it. This could be seen as we're not seeing the complexity, we're only seeing the necessary parts or the necessary components towards what needs to be achieved. And this idea of abstraction applies all throughout our everyday lives. So, for example, a very classic example of abstraction is making a sandwich, like a peanut butter jelly sandwich. When we talk about making a peanut butter jelly sandwich, a lot of the details of making the sandwich are oftentimes not mentioned due to things like we just assume or people already know what our intentions are when we say specific phrases. So, for example, if I say the ingredients necessary for a peanut butter sandwich are bread, peanut butter, and jelly, there is a whole plethora of details behind that one sentence. What kind of bread, what kind of jelly, what kind of peanut butter. And we don't mention those things oftentimes because it's assumed that the person that we're talking to will already think about those things. The next step is to grab a knife. And then again, there's a lot of behind the scenes as to what that means. Most people know when we say grab a knife that we mean something like a butter knife. So we're not saying like grab a steak knife, grab a bread knife, grab a meat cleaver, right? It's assumed in a lot of these things. And it goes on, right? The logistics of spreading peanut butter, right? We don't worry about do we grab the handle? Do we grab the blade, right? How do we put the knife in the jar, right? A lot of those details are hidden when we talk about it in everyday speech due to things like we assume or we just already have a general understanding. The difficult part in just creating things programmatically is we don't get the luxury of those assumptions, right? When we build our workflows, when we work in Jinja, we have to define all of those intrinsic steps, right? The what is step one, step two, what is each line of code? All of this has to be detailed out as we build our things. But that doesn't necessarily mean we need to show or reveal all of those things in the workflows that we end up building as parent workflows. So all of that to sum up what is abstraction, right? We only expose what is necessary. Usually, this is in the form of things like inputs or parameters. As long as we have what inputs are necessary, all of the complexity is usually hidden from us somewhere else. The unfortunate part here is that oftentimes we are the ones who have to build the complexity. In the building process, when we leverage this idea of abstraction, we want to do our best to keep things as simple as possible in the process of hiding the complexity. If we can try to simplify the complexity that we are hiding, that makes things much easier to manage, easier to deal with in the long run. Right. So we use abstraction for simplification, for reusability, and for layering. Those are generally the big ones that we're focusing in on. Now, when we talk about abstraction in our automations, right, again, we're just going to be emphasizing our sub-workflows. Now, when we use abstraction, one of the big benefits that we get from abstraction is this idea of dry. Don't repeat yourself. We talked a lot about the benefits of dry back over in Roost 2.01, but just as a quick recap, when we remain dry, it gives us things like easier maintainability, more clarity in the workflows that we build, and consistency, right? We have a very natural, repeatable sort of paradigm or methodology towards building our workflows, right? So a very classic example of abstraction in action are vending machines. How do vending machines work behind the scenes? Very few people really know, right? What gears are involved, what circuits are involved, what logic are involved is not really a big concern to most people using a vending machine. The only things that do matter to us is what's revealed, right? What is shown to us, right? What's shown to us is the items in the vending machine, and what makes the vending machine work for us in our perspective is money, right? Putting in coins or dollar bills or tapping our credit card, and the input, right? What item do we want? So all of the behind the scenes of what makes the vending machine work are hidden to us as the consumer. All we are concerned about is what selection do I need to make? How much money do I put in? That in essence is abstraction in action, right? Of course, again, we are the ones concerned about how does the inner workings of our vending machine, our modules work, but we also are concerned about the inputs that need to go into our vending machine. So when going through abstraction, how do developers, how do programmers do this? What are the big concepts and ideas of abstraction that they need to keep in mind as they build out these things? So in the programming world, when we are using abstraction, most of the time this is in regards to writing what are known as functions. Functions are chunks of code that do something, whatever that something is. And so when a developer is thinking about writing a function, they usually think about it in these ways. First, they need to think about what is the purpose? What is the function going to do? Once they've defined what its purpose is going to be, they'll specify then what are the inputs that need to go into the function to make it work. And if anything is going to come out of the function, what are the outputs? What are we going to get back, if anything? And then once they have those things in mind, it's just a matter of creating the function. When we write functions, in order to use a function, right, it's very straightforward, right? We just need to know which function to use and what the function is going to do for us. What are we going to get? And in order to make all of this work, what do we need to give the function in order for it to, well, function or work? By doing so, right, we are not concerned about the complexity, right? That is already taken care of. And if we make any changes to a function, anybody who is using that function will also gain or inherit those changes. It makes that easy to configure, very, well, easy. You only need to make the change one time. So you can reuse the function over and over and over again. You have one centralized area that you'll make the change, And again, you don't need to either retype or add these massive blocks of code everywhere. It's usually just one line of function. And we've seen this already in Jinja. An example of functions in Jinja could be our filters, things like the lower filter, the join filter, things like that. There's a whole lot mess of code behind the filter in order to make them work, right? We aren't concerned about it. Most of us probably have never even seen it, right? We are just concerned about, is there anything we need to give to the filter and what is it going to do for us? Now, when it comes to creating a function, there's a couple of paradigms or a couple of things that we should keep in mind as we do. Things like a function, generally speaking, is going to be designed to do one thing. This is known as the single responsibility principle. The functions that we make should do just one thing, and we try to keep it as small as we can. It should only have one thing done, one specific outcome. As we think about what is its purpose, what is the one thing that it does, we should give it a very descriptive name to describe what that one thing is. Again, following that verb noun paradigm, things like create list, get user, things like that. And you can even be complex with it. So things like get calendar by user ID, get ticket by ticket type. Right? Those kinds of names, very, very descriptive, right? Doesn't really leave a lot of room to misunderstand what it's going to do. And finally, when we're thinking about creating functions, we should make sure that there isn't anything else that's happening that we don't expect to happen, right? These are the side effects, right? So if we are getting a list of users, we don't expect users to be modified along the way. If we're creating a ticket, we don't expect anything else to happen besides creating the ticket. So we should have, again, very purposeful, very intentional, very transparent as to what that one thing or that one responsibility is. Now, taking all of those concepts that we just talked about and applying it to Roost, everything again is very, very similar. When we think about functions in Roost, these are sub workflows. We can create sub workflows as if we were creating functions. And so all of the principles that we just talked about are applicable to creating our sub workflows. So things like, what is the purpose of the sub workflow that we're going to build? What are the inputs or the parameters that are going to go into the sub workflow to make it run? And if anything needs to come out of the sub workflow, what is it? Right? We can declare all of those things. And then the hard part, right? The hardest part of all of this is actually building it. And so we're going to talk about a lot of different strategies to help build our sub workflows or just workflows in general. But again, all of this is all of this is built on the foundation of Aaron's law. You cannot automate a process that doesn't exist. Right? So we are always going to consider how do we bring that process into existence before we start building our sub workflows. And again, same principles as creating a function are also applicable in creating our sub workflows, right? What is that one thing, one single responsibility that that sub workflow is going to have? Once we determine that, give it a very descriptive name, right? What is it that it's doing? Give it a name that reflects that. From there, again, no side effects. We don't want anything to happen that we don't expect to happen based off of its single responsibility and the name that we gave it. Right. And so with that, again, other things to think about are how many inputs are going to go into the sub workflow. Ideally, we want to have it as minimal as possible. We don't want to have more data than we need to work with. When we're building sub workflows, we can also use other sub workflows as well, right? Utilize what we've already built and just make sure that we test it a lot, right? Using that test button frequently to ensure that the functionality of the sub workflow does what we expect. So quick example here. Let's suppose that we are creating a ticket. right? And so we can create a ticket using our ticketing systems action, our PSA. But if we ever decide that we want to use different ticketing systems, maybe we can use a sub workflow to help us out with this. And along with that, maybe there's a lot more steps involved in the greater ticket that we are creating. Maybe, for example, we're going to grab some data from somewhere. We're going to parse that data, massage it to get the exact data that we want. We take that data and maybe we put it in the description of a ticket, right? And so all of those other steps to help us along the way, right, are things that we might still want to do regardless of which ticketing system that we're going to be using, which PSA. And so this is a great example of using a sub workflow. You have all of those other steps contained inside of the sub workflow, right? And the only swap or change that you need to make is just which PSAs create ticket you're going to use. And if we ever need to do this somewhere else, right, we can take the sub workflow and use it somewhere else. So we don't have to re-implement the same 3 or 4 actions wherever we go if this is going to be used very frequently. So just one example of how we can use sub workflows to our advantage. Now, 80% of the time, we are going to see abstraction through sub workflows. But there are other instances where we can see abstraction in action. One of those is in Jinja. Now, in Jinja, we can write functions. And when we write a function in Jinja, these are known as macros. So you can write a macro in Jinja like so, and then you can reuse that macro in the Jinja editor that you made it in. One of the things to consider is that wherever you make the macro, that's where it's going to exist. So this is very useful if you're going to be using the same sort of function or macro again and again and again throughout the Jinja editor, the Jinja block of code that you're working with. So wherever you make the macro, that's where it stays. That's the scope of the macro that we create. So we can write functions in Jinja. They're just called macros, and they stay exactly where you made it. Now, other places that abstraction can kind of live, right? There's a whole section that you can store your scripts. So you can pull scripts from that section. And then that's also the same with some templates as well. Now, all of this is sort of fine and dandy, but one of the temptations that some people have when we talk about abstraction is taking something that's really, really complex and then just kind of drawing a box over it, and that's your sub workflow, right? It has all of this complexity, all of this stuff behind it, and this is actually technically an anti-pattern, something that we want to avoid. These are known as God functions. Sometimes you'll hear them as God objects or even God automations. But basically, the idea behind it is whether you're creating a function or a sub workflow, a God function is when a function is extremely complicated and is trying to do literally as many things as it can, having many, many responsibilities, right? When we have something like that, it becomes very difficult to manage. There's a lot of different levels of abstraction. And in doing so, again, it creates more complexity, more prone to errors whenever we try to enhance or fix things. And it's just kind of a maintenance nightmare when we're working with these God functions. And no, and generally, we know we're working with a God function or a God workflow when we zoom out and we kind of stare at it and we're not quite sure what's happening, or it's very difficult to decipher what's going on. And so God workflows and God functions go hand in hand. A God workflow is the same idea, where you try to take all of this complexity and just shove it in one workflow, right? It has a lot of conditional logic. So it might have one really big no-op with like 8 or 9 transitions trying to account for all of these custom conditions. And when we look at these God functions and God workflows, oftentimes we are doing the opposite of building modularly. We are building monolithically. And we'll talk more about sort of the differences between those two terms. Now, just looking at a God workflow, it's really difficult to maintain, right? Again, just looking at what we saw previously, it takes a lot of time to figure out what each component of the workflow is doing. If you wanted to build upon that workflow and test it, we would have to run the entire workflow, right? And sometimes when we're going through situations like that, one simple change in a big God workflow like that could break the whole thing. And sometimes it's not always clear which part of the workflow is broken because of one simple change that we made. And so that causes us to spend more time debugging and ultimately reducing the amount of time that we're actually saving in the workflows that we're building. And so when we think about building workflows, again, we want to think about building them as if we were building with Legos, building them modularly, right? Using sub workflows, being very strategic and deliberate in how we set up our conditions and continuing to optimize the existing sub workflows that we're working through. So we'll cover a lot of the modularity aspects pretty soon. But last big thing that we're going to carry with us before we start talking about the other concepts is trying to keep things as simple as possible. Right? This is the KISS principle. When we think about keeping things simple, it's in its name, right? What is the simplest way that we can try to build something, right? How can we keep our workflows? How can we keep our Jinja simple so that way the complexity, the scope creep doesn't sneak up on us and introduce more parts that we need to figure out, more parts to build, et cetera, et cetera. And so again, a lot of where we've come from so far can be summed up in KISS as well. Things like focusing on what's the most important thing, what is the single responsibility that needs to happen within our code, within our sub workflows, within the greater workflows that we might be building and using sub workflows for. Right. So with that, let's dive into this conversation of modularity and monolithic, since we've kind of teased it out a little bit. Let's first define the paradigms behind these two things. When we talk about building monolithically, right, mono being one, we're usually thinking about building something as one big or just one cohesive unit. And when we build monolithically, the benefits of it is that it's fast, right? You can build something very quickly if you take the monolithic route, right? And if you're building something that's very, very small with like 2 or 3 steps involved, then monolithic is generally the approach that we want to take. One of the aspects of a monolithic design, because it's one single unit, is that everything is very tightly coupled or tightly integrated or tightly dependent on each other. As we see in our workflows, right? We see everything that is connected along the way. When we think about building monolithically, oftentimes the analogy is building with clay or building with Play-Doh, right? Very easy to shape clay the way that you want, exactly how you want. But once it dries, once you shove it in a kiln, then you're kind of done, right? Making additional changes to something like clay or Play-Doh after it dries can be very, very difficult. And as you can imagine, as monolithic systems or workflows grow, it's very, very hard to maintain them. It's very hard to scale them. It's very hard to debug them because everything is one big unit. Everything is dependent on each other. We have to test the entire thing. And again, introducing one change in a very tightly coupled, tightly dependent system, right, could break something from step 1, even though we're on step 30. So monolithic is fast And it is useful when we're building things very small. But once we start growing with a monolithic design, that's where we run into a lot of the problems with monolithic designs. Now we contrast that with modular design. And modular design, again, the analogy is as if we're building with Legos. We think about building modularly with independent parts or independent modules. When we think about Legos, each piece, each Lego piece, sticks together very nicely to one another. That's how they're built. Different pieces have different functionality, different intentions as to why they were built. And it's just as simple as combining all of these pieces together to build whatever sort of system or design that we're seeking. Now, when it comes to modular design, the drawback of modular design is that it does take a little bit of time, right? It takes time to plan. It takes time to be strategic in how we build modularly, and it takes time to build the modules, right? Build the sub workflows, right? Those things do take time. So if there was one drawback that we should highlight when it comes to modular design is that it takes strategic planning and it takes time. But with modular design, all of the drawbacks are front loaded, right? We account for that in the beginning, knowing that all of the benefits of modular design are going to come at us as we build and as we deploy and run our automations. Because with that, with a modular design, it allows for much greater flexibility, right? We have modules that we can use in other workflows. When we make changes to a module, a sub workflow, that change is given to any other workflow that's using the sub workflow. So we only need to make the change in one place, the sub workflow. And it allows us to scale much easier, right? We're not stuck with visually huge workflows. Again, we can reuse the components very easily. And if we do need to make a change, we know that the change is isolated inside of the sub workflow. So that if we do something in the sub workflow and it breaks the greater workflow itself, we know that the change that we made in the sub workflow is where it's going to be. It's sort of isolated in that environment. There really isn't anywhere else that we might need to make that change. Right? So a lot of big benefits with modular design. And ultimately, in the long run, we're saving much more time in debugging, in troubleshooting, in scaling. And again, with a modular design, we don't need to spend all of that time trying to figure out the greater workflow of how everything works, right? We just need to figure out what's happening inside of that one single sub workflow, right? Reduces the amount of time we need to figure these things out. So in essence, monolithic design is good at building fast and building small. But once we start growing bigger, once we start scaling, modular design is going to be the approach that we are almost always going to want to take with the automations that we are creating. So how do we do all of this, right? How do we build our sub workflows? How do we think about a lot of the concepts that we've talked about so far? And there's many different ways to bring our processes into existence. And so the one that I want to highlight here is pseudocode. Now, pseudocode, just in its essence, is just thinking and writing programmatically without any sort of concern about the syntax or the structure of any coding language. So pseudocode is not actual code that we're going to run on any computer or machine, but it's writing as if we were coding. And what I personally really like about pseudocode is that pseudocode sort of acts as a bridge between how we think as just everyday people and how we would think about problems and solutions if we were actually having to code something. And so, for example, sometimes when we think about how to solve a problem, we think about it just in everyday sort of human terms. But the issue is, if we were to directly translate exactly how we think of a solution, just as human beings, and implement that solution in code, sometimes we encounter a lot of inefficiencies along the way. And if we try to force a human thought up solution without considering how it's interpreted programmatically, we can run into a lot of issues. We can run into maintenance problems. We can run into efficiencies. So what I like about pseudocode is, again, it sort of takes us a step beyond just thinking about the solution in human everyday thought and think about how would we approach this problem as a developer through code or through Roost. So this is sort of the nice part about pseudocode. And when we approach how to implement pseudocode, a lot of this is just very similar to how we would plan a project in general. Right? We would first, of course, think about what is the overarching goal, break down the process, write the pseudocode, take a look at it, and then implement it within Roost. So when we first think about defining the goal, we can rewind all the way back to Roost 101 and think about Aaron's law. Right? You cannot automate a process that doesn't exist. So we bring that process into existence. What is the thing that we are looking to automate? Right? What are its steps? Right? And then applying the things we talked about here. Right? What is the primary purpose of the automation? What are the outcomes that we expect? How can we measure these things against whether it's KPIs or outcomes? When we think about defining the goal, again, we should focus in on that one thing and focus in on the singular first. Oftentimes we think about, I want to do this task for all users. That's usually a very common use case. Like, I want to get all of the users that are admins, for example. So before we scale to all of the users, during our goal, we should focus in on the singular, right? How can we get one user and see if they're an admin? And we can always scale it to all users using with items. So singular focus as well as singular action. Try it for one ticket or one user or one device first, and then we can always scale it up very easily with items. From there, breaking down each of our tasks, right? What are the individual actions that we need to keep in mind as we are going through the goal? And as we identify those actions, we want to ask ourselves, can we make this a sub workflow? Is this something that we might use again and again throughout our automation journey? So breaking down each individual task, right? When we're drawing, oh, that's a different one. So from there, once we have those things lined up, we can write out the pseudocode. And during the pseudocode process, this gives us a great opportunity to define what are our inputs, what are our outputs, as well as start thinking about names for our data aliases, for our actions, for the variables that we're going to be working with. Again, sometimes the hardest part in building our workflows is determining what do we name a variable that we're going to create? What do we name a no-op that has something in its transition? And oftentimes, I know for me personally, sometimes I just make something up on the fly and just kind of leave it at that. But with pseudocode, we get that opportunity to spend some time thinking about this, right? Writing it down, and then if we want to change it, we can always just erase and change it right then and there. Right? So it makes it much clearer as to what these names are going to be, hopefully with the intent of making these very descriptive, following the principles we talked about in Roost 202. Review and optimize, it's in its name, right? Walk through the process, right? And ideally walk through it manually, right? Seeing, does it achieve the things that you expect it to do, right? If you write out the Jinja right then and there, throw it in the Jinja editor, see if it does what you expect it to do. And then finally, just make the workflow within Roost. Right. So with any approach we take, right, it's going to give us a whole plethora of benefits when we outline and bring the process into existence first. How you guys decide to do it is completely up to you. Whether you want to draw it out, whether you just write out the steps in pen and paper or in a doc, however you do it. But we just wanted to bring up pseudocode again, just as another tool in your toolbox so that we can more easily bridge the gap between how do we think as people, how do we think as developers, how do we take those two things and implement it efficiently within Roost. And so with all of that, that does bring us to the end of Roost 204. As always, I'm going to thank you guys for learning Roost, learning Jinja, learning these concepts with me. If you have any questions, feel free to stick around. But otherwise, if no questions, hope you have a great rest of your Thursday and hope to see you tomorrow in the open mic.